All right, good morning, AP Chemistry class at TAS. So today is Wednesday, August 31st, 2022. It's Mr. Mac, and so you have noticed by now that I'm not at the school. Like I said, I would be gone in Thailand, which I'm at now, taking care of visa issues. So I'll see you guys next week. But here is a pre-recorded lesson for you guys to watch and then take notes or if you need to, and then you may do the assignments that I have given you, and they should be printed out for you already, available in the classroom from your cover teacher. So anyways, let me begin the lesson now. Okay, so one of your sheets that I gave you, some of you did this already. I think, hey Ben, you did this? I'm not sure. You finished it already, so we'll go through this quickly, but then I really want to teach you more about how to balance equations and identifying the different types of chemical reactions for today. So this stuff is going to be a review of the very basic chemistry of the atomic structure that you need to know. So let's go through that first. Okay, so for the atomic structure, really, you just need to know your periodic table. Now, let me show you the American periodic table. The lovely periodic table, which I will post for you on the Google Classroom, my version of it that has everything you need. So this is the American lazy man's version of the periodic table. So as you can see, okay, in the boxes here, every box of every element, the information that you have is atomic number in the upper left, atomic mass in the lower left, and then this stuff will be valuable later as we get into the other chapters. So just pay attention to atomic number and atomic mass for now. So, all right, now, the stuff that you need to know for your worksheet is very simple. You just need to basically know like your protons, neutrons, and electrons. So if you remember in your atoms, you should already know that these are your main subatomic particles that belong to the atom. So basically you have the headquarters or main office of the atom, which is the nucleus that contains your protons and neutrons, right? And then on the orbits or rings or shells around the nucleus, you have the electron, okay? So these are your three main subatomic particles. We do know that within the proton can be divided up into quarks and other stuff like that, but we're not worried about that here. So now this is very similar to the solar system in space. That nucleus is acting like the sun, where the electrons are like the planets circling around the sun or the nucleus, like in orbit, just like we have in the macroscopic size of our space solar system outside the Earth. So the atom in the microscopic universe is very similar. It's almost done like that by design. Very interesting. But anyhow, in the atom, you have these three main subatomic particles. Okay. Now, of course, in real life, the atom does not really look like this. The atom is going to be more 3D. And then the orbits will be a little bit in and out of the page and at different angles. It's not just flat 2D like this. And the electrons certainly do not just sit still and just sit there. They will be moving around like crazy. Okay. We'll talk about that more when I come back to school, the actual 3D model of an atom. But for now, this is the simplified secondary school version of the atom and the atomic structure. So now, how does the information in your periodic table give you any information relevant to that picture? It's all this stuff, okay? So first, let's talk about the masses. In your atom, most of the mass is contained within that nucleus, contained within where the protons and neutrons are. Whereas the electrons are not mass of zero, but they're really, really, really small compared to the protons and neutrons. So we approximate them at zero for the electron's mass. But most of the other parts of the atom is mostly empty space. Just like the vast distance between the planets and the sun is a lot of empty space, right? We have so much distance between the planets and the sun. I mean, our solar system is just a small part of the universe, but to the human, it's still so much bigger. And we're just like just specks of nothing compared to the size of the, of what's out there in space. So anyways, the proton has a mass of 1, neutron has a mass of 1, the electron is almost 0, and the protons would be what has a positive charge. The neutrons, just like the word neutral, where you don't really take any side, good or bad or whatever. The neutron is a charge of 0, okay? No charge at all. There's no positive or negative. And the electrons will be the ones that have a negative charge. Now, the masses will balance each other out, and the charges will balance each other out, okay? Mostly. Well, not the mass here, but like the charges would definitely balance each other out, okay? Positive and negative charges. So you have to have an equal number of protons and total number of electrons in the atom to balance the overall positive and negative charges, okay? That's why every atom on your periodic table, when it's just a pure atom, has no charge. It's only when they lose or gain electrons is when they become ions and have a positive and negative charge. So in the periodic table you see here, this ion charge up here is only when these atoms will lose or gain electrons. But on their own, in pure state, they will have no charge at all because you balance the protons and electrons. Okay, so now there are 2 versions of the periodic table. In the UK version, because they hate America, they have this flipped. Notice here, if you have carbon like this, 12 is top, 6 on the bottom. On the American version, you have it the other way. In the American version, the 6 is at the top, the 12 is at the bottom. Understood? So the difference is that the American version has the atomic number, the AP chemistry version, which is important for you guys. The atomic number is on top, the atomic mass is on the bottom. Got it? The UK version will have, it flipped. And the reason why I'm using a British PowerPoint is because they have better PowerPoints than the lazy Americans who make up the PowerPoints. The Brits have better presentations of these things for science class. Anyway, so this is the UK version of the periodic table. But anyhow, no matter which version you have, American or British, the atomic number will always be the smaller number, and the atomic mass will always be bigger, okay? Now, the atomic number, the smaller number of the two, will always represent the protons that you have in a nucleus. So it's a proton number as well. It will tell you exactly how many protons you have in the nucleus, okay? And, okay, just to get to the point, the mass number. The atomic mass will be a combination of your neutrons and protons together to give you that mass. You understand? So this is some example done here. Now, by the way, this British version is not good because it just rounds it to whole numbers. The American version, if you notice, will have decimals in the atomic masses because these are the way the periodic table should look. These masses are estimated because they are like taking a weighted average of the different isotopes of all the atoms. We'll talk about that next time. But for today's assignment, you don't need to do that yet, okay? We'll get more into that in this chapter. Okay, so anyhow, for this, the mass number, again, atomic mass is number of protons plus number of neutrons. Understood? So basically, just add them all up together, right? For all your elements, no matter what element you have, you add your protons and neutrons, and you get your mass. Got it? And again, your atomic number will tell you your protons. Now, for electrons, the electrons should be all equal to the protons. Like I said earlier, to balance the positive charges of the protons, the negative charges of the electrons will balance those protons, so they have to be equal. That's the total number of electrons. Not the electron on the last shell or the second shell or the first shell, but all the electrons combined together should equal the total number of protons in the nucleus. Remember that? So basically your atomic number is telling you not just the number of protons, but also the number of electrons you have, the total number of electrons. Okay, with that said, you should be able to get Okay, so all this information here should allow you to be able to get that worksheet that I gave you last week done. This one, okay, which is given to you in a handout today. So fill that in, and then we will go into balancing chemical equation and type of chemical reactions, right? So let's go to the next presentation. Chemical equations. Now, I don't want to talk about all this other stuff yet. I just want to talk about how to balance a chemical equation. Now, why do we care about balancing chemical equations? It's because there is something called the conservation of mass, okay? We have to follow this rule called the conservation of mass, or basically it is the law of the conservation of matter, okay? So basically, from this very old rule of chemistry, mass cannot be created or destroyed. That's what we call conservation of mass or matter. Okay? So basically, whatever the heck happened on the reactant side, in terms of amount of mass, must somehow be equal to all the mass that is made on the product side, on the right side of the equation. So that is a fundamental rule you must follow. Now, of course, in the real world, some of the mass gets lost as different forms, or leaked out as a liquid, or floated off as a gas, escaped as a gas, but for the most part, all the mass has to be equal before and after the reaction. And that is why you balance the chemical equation. So all the atoms, okay, must be equal on both sides of the chemical equation. Now, I don't know how much you did this when you did chemistry last year, but the principle is this. You must, okay, make sure that no matter what compounds or elements I have on both sides, there's equal number of atoms of every element on both sides of the chemical equation. You understand? So we are going to deal with these things, the coefficients. You are not allowed to change these tiny numbers, the subscripts. You're only allowed to change the coefficients in front of every element. You understand? And there are some set of rules that you should follow when you balance equations. Now, the idea is this. It's like a seesaw. You're trying to balance them like this so that everything will be balanced like this, so that you have a balance between the left side, reactive side, and the right product side, right? Equal number of every colored atoms on both sides of the equation. Understood? That is the real reason why we're doing this. Okay, to make sure everything is equal for every element. Okay, so, sometimes it's easy when you don't have a lot of stuff in that reaction, but sometimes it's a lot uglier. So let me show you a more ugly one, like these guys, okay? So you could have these, okay, nasty reactions. So some general rules for you to follow, okay? Polyatomic ions should come first. You understand? What are my polyatomic ions? Well, this will be included in the Google Classroom today too. And these, okay, I'm having a little trouble with this. Let me show you what it looks like. Common polyatomic ions. I am going insane now. My computer is just getting slower every day. Okay, these bad babies, I'm sure you've seen them before, right? In general chemistry. But yes, you need to memorize like almost all of them. Well, mostly. I would definitely memorize all the ones that have an 8. Okay? 8. And hydroxide. You understand? And ammonium as well. Okay, let's talk about what they are in case you guys do not know. These common polyatomic ions are basically like a bunch of friends in high school that always hang out together. You know what I mean? They just hang out together because they like each other, they're close friends. And then they give themselves some kind of weird name and weird like code or whatever. So it's like these common polyatomic ions are like groups of friends that just stick together in a social setting. And then they form like a weird arrangement of whoever elements, and they assign their own charge and they have their own name, okay? So that's what they are. But unfortunately, most of these look ugly. So good luck to you on this one. The only way to really get good at memorizing these for your AP chemistry test is to use flashcards and put them all on a card with both the name on one side and the symbols and charges on the other side, and just flip through that thing like an animation book. Got it? So yes, but anyhow, these are your polyatomic ions. And so you need to balance these suckers first because they are a pain in the butt. Understood? So balance them first, the common polyatomic ions. Then when you deal with that, I would suggest not this. This is an outdated version from a textbook that I don't use anymore. But I'm going to update this a little bit with what I want you to do. So forget about that. Let's change my rules a little bit here. Okay. What I would like to do is tell you that when your reaction is really kind of not nice, okay, I suggest that you do, for number 2, do metals next. You understand? Do metals next. Now, probably doesn't really matter if you have a group 1 or group 2 metal like sodium and magnesium. You could have a transition metal in the middle of the periodic table, like, copper or iron. Doesn't really matter which of those metals you do first, because you have to get to the other one later anyway. So just do the metals first. Next one, do a non-metal. Okay. Except hydrogen and oxygen. We'll leave them last. Okay. The non-metal, whatever non-metals you see, that's all the elements on the right side of the periodic table. Shame on you if you do not know that yet. So anyways, this one, non-metal, do it. And then if there's a halogen will come later. You know what a halogen is? Group 7? Like Cl, F, Br, I. Okay, that would be last in that first glance at non-metals. And then you may do after that hydrogen. Oh, sorry. Didn't write that with a lowercase. Hydrogen H. And then last but not least, oxygen. Understand? Now, if you have a combustion reaction, okay? Sorry, combustion. You know how to spell that. So basically, it has something like this. We'll get to that later. This is one of your 5 types of chemical reactions. It's not on your worksheet though, but you should know it. Something that's a hydrocarbon compound that has carbon and hydrogen with oxygen, and then they burn together, and then you produce CO2 plus water, carbon dioxide and water, okay? So when you have only carbon, hydrogen, and oxygen in the same reaction, always, okay, balance carbon, then hydrogen, then oxygen. Understand? Yeah. So basically, Cho, like some Korean person's last name. Okay. So this is CHO. Okay, so that's for combustion. But everybody else, you do number 1, 2, 3, 4, 5. So try these methods. Take notes on this, definitely. Take a picture or whatever. Okay, and save that, because I will never show it to you again. Just kidding. I might show it to you someday. But yeah, this is it for balancing a chemical equation. All right, so then you will have this worksheet to do all that. Nightmare. Okay, so like this one, number 10, for example, do the nitrate NO3 first. Then do PB, because that's a metal. Then do a non-metal like sulfur. Then do hydrogen, then do oxygen. Well, I think if you did the nitrate already, the oxygen should already balance itself out eventually by the end. Okay, if you could do it in any order, but if you do it out of order, you could be doing it in a loop, like a trial and error. It could take you longer. You don't have time for that on your AP chemistry test, right? You need to get the balanced equation as soon as possible. So follow my order, okay? Always do metal first, and do any non-metal except hydrogen and oxygen, then do hydrogen, then do oxygen. Or in this case, polyatomic ion first for number 10, then the metal like Pb lead, then a non-metal like sulfur, then hydrogen, then oxygen. Trust me, it will work out just nicely, all right? Hopefully, okay? In case you mess up your math, then, well, you have to try again. So now, when you have this situation, if you have a fraction in one of your reactions, multiply everybody by 2 to get that 13/2 to be a whole number. Do you understand? So that everyone would be a whole number. And then you can reduce it to lowest terms again if you can. Otherwise, just get everyone a whole numbers and we'll be okay. No decimals, no fractions on your coefficient. You understand? So make it look like this. So there's whole numbers only. Okay, I think you have the general rules for balancing a chemical equation now. Okay, now I'm going to go into the types of chemical reactions. Okay, so the types of chemical reactions. Okay, now there are lots of reactions in, oh my God, chemistry. But there's really only 5 main categories. The first one I already told you was combustion, right? That has carbon, hydrogen, and oxygen elements only. So the hydrocarbon was oxygen to make CO2 and H2O. But, okay, so let's just show the whole list here first. So the first one I talked about was combustion reaction, this one. This CH is any hydrocarbon compound. Any compound that's organic made out of hydrogen and carbon, right? And you always make these things. Now, here are the other ones. This is number 2 reaction. Synthesis, combination reaction. It's basically like a marriage reaction. A and B get together to make AB. So if I had to describe it in my vocabulary, you are in grade 12 and 11. So you guys can use this kind of inappropriate words. So, well, you see why it's inappropriate in a minute. The marriage reaction, okay? A man and a woman, could be a gay couple or lesbian, but whatever. So this is a man and a woman getting together to make a happy couple. That's the honeymoon phase. And then, well, things fall apart, you know. Then they hate each other, you know, like Angelina Jolie and Brad Pitt. And then they get a divorce. Divorce reaction, okay? That's an R, by the way, R, not V reaction. You understand? Divorce reaction. So the happy couple is now divorcing and splitting into the original elements. Then the fourth type of reaction is single replacement reaction. Now, let's pretend this guy is you know, a boyfriend. And B is another boyfriend of, you know, and this is a girlfriend. Okay? Could be gay or lesbian couple, but you know, let's just talk about opposites first. Now, boyfriend, and girlfriend. So this boyfriend is like, I'm gonna steal this girlfriend. So he's gonna kick that boyfriend out. And well, now he's all alone. Cool guy. So a single replacement reaction is also known as the boyfriend or girlfriend stealing reaction. Okay. Otherwise, it's known as the homewrecker reaction. I like that word more. But it's a home wrecking reaction. A is gonna home wreck this couple, okay? And then we'll form a new couple. All right, so that's single replacement. And the last and fifth type of chemical reaction is double replacement reaction. So this A could be like a metal. Sorry, I'll talk about metals and non-metals later. So back in single replacement, A could be a metal, B would be a metal, C would be a non-metal. So that A metal would replace this B metal and get together with this C non-metal. Now, in the double replacement, I will have 2 couples. This metal and this non-metal and this metal and this non-metal, 2 different couples. So this is husband 1, husband 2. A is husband 1. C is husband 2. B is wife 1, D is wife 2. And somehow these couples, after some time, they got sick of each other and they want to switch partners. So they're going to switch and now they form new couples. So A will get together, A husband will get together with D wife, and C husband will get together with B wife. So basically we call this the husband-wife swapping reaction. Or otherwise known as the bored married couple syndrome. And it happens in the real world. That's the fifth type of chemical reaction. Can you believe that human nature, I think people, they cheat on each other or they, get into bad relationships because they can't help themselves because of all these chemicals in their body dictating the way they behave in real life? Who knows? But some student got a really high score in the IB diploma, writing an entire essay about this when he was graduating from the IB diploma. How interesting, right? Anyhow, now, what about these other ones? The neutralization reaction, okay? Where did this one come from? Okay, so where does this neutralization reaction come from? Combustion reaction, we already know. So the 5 types is combustion, synthesis, decomposition, single replacement, and double replacement. So then where does neutralization and polymerization come in? Well, they're just different types of the other ones above. Neutralization reaction, which we will get to in the acid-base chapter, is basically like double replacement. And polymerization is really like synthesis and decomposition, where if you have decomposition, it's one bigger compound breaking into smaller parts, or all these smaller parts joining together to make a bigger compound, like synthesis, okay? So they're not really their own categories because they follow still these ones listed above, right? So your main types are combustion, synthesis, decomposition, single replacement, double replacement. Anyhow, not to make this video super long, okay? So let me go back to the other thing here. Oh God, I'm stuck on this thing. Okay, so on the worksheet that you have, okay, guys, you are to do, right, not just the balancing of the equations, but you may label them as synthesis, decomposition, single replacement, or double replacement on the right blank spaces. None of these are combustion, so don't worry about that, because that's too easy to recognize, okay? So that's all you're going to be doing on this worksheet. I hope I explained everything you need to know how to do, okay? I will be posting the periodic table and the common polyatomic ions on your Google Drive or the Google Classroom for AP Chem. So you guys have a great weekend. I'll see you next week. Be safe and have a good time and relax and rest up. And yeah, good luck to you and see you then. All right, bye for now.